So once we connect to Postgres, we can then start to do stuff. And so here is our getting our connection, right? So we're using SQL Open, and we pass in the driver name, and then we pass in our connection string. And you can see this connection string is using the URI method. If I was to rewrite this code, I would use the key value method. I like the way that looks better. We just did that in the previous video. And then we check to make sure we're actually connected to our database. And then here, and this is a preview of what we're going to see, we have our database connection, right? That DB. And when we do that, when we use SQL Open, so we're just going to understand documentation here. I'm in package SQL. And if I go to the index, when we use Open, it gives us back, which we just used Open right here. It gives us back a pointer to a DB and an error. What's type DB? Pointer to DB. Here's type DB. And if we have a pointer to DB, we have all of these methods available. So we have a pointer to DB, and we have all those methods available. And one of those methods right here is query. And if we do a query, right, like give it a query string and arguments, which could be an unlimited number of arguments of any type. So if we do a query, which is like this, db query, query string, and then this one has no arguments, right? Unlimited, including 0 arguments, and args if we need to pass in arguments. Just looking at that. Here is our query, and that goes to query context, and query context has args, and args go to, so I guess if you add additional complexity, you could do that, but we're not using any args. But that gives us a pointer to rows. So if we do a query, we're going to get rows, right? We ask a question of the database, we'll get rows back. What are rows? Well, here's type rows, and if we have a pointer to rows, we have all these methods available. We have close. We have next, like give me the next row, right? We have scan and destination. So maybe we scan that row and put the data into a certain destination. We have columns, so we can see the column names. So if we have rows, we could get this data out. One thing I'd like to see would be how many rows were actually returned, like length, but I don't see how to figure that out. Maybe if we have that query, DB, that's the query, yeah, it doesn't tell us how many rows. I guess we'd have to count them. Next, result set, scan, error, columns, close. Type rows. Contains filtered or unexported fields. The cursor starts before the first row of the result set. Use next to advance from row to row. So if we look at next, next prepares the next result row for reading with the scan method. So next prepares the next result row for reading with the scan method, reading with the scan method. So we're going to read the row with the scan method. So we say, give me the next one. And then when we get it, we're going to read it with scan. That's what that line's telling us. Next returns true on success or false if there's no next result row or an error happened. Error should be consulted to distinguish between the two cases. Every call to scan, even the first one, must be preceded by call to next. So we call next and then we call scan to get the data. Scan copies the columns in the current row into the values pointed at by destination. Destination, unlimited empty interface, unlimited number of values of empty interface, variadic parameter, 0 to unlimited. So they could be of any type, but they have to be pointed at. by destination. What's pointed at mean? What kind of values am I going to have here? Pointed at means they're going to be pointers, which means they're going to be addresses, right? Pointers, addresses, pointed at. I either, give you the literal value, or I give you the address, which is also a value, but it's pointing to a location in memory, so we call it a pointer. The number of values in destination must be the same as the number of columns and rows. So if we have 4 columns, we need 4 places to put data. Okay? What that looks like, and by the way, there's also close. Closes the rows, preventing further enumeration. If next is called and returns false, and there are no further result sets, the rows are closed automatically. And it will, and it will suffice to check that's not what I wanted. And it will suffice to check the result of error. Closes idempotent and does not affect the result of error. Idempotent. Denoting an element of a set that is unchanged in value when multiplied or otherwise operated by itself. Unchanged in value. So closes idempotent and does not affect the result of error. So what that looks like is we have our DB. We do a query, we give it the query, we get rows back. We're going to defer rows, close. If there's an error, we'll panic, shut our program down. Then we're going to make a data structure to hold our results. We have type book, which has 4 fields. Just data structure, aggregates together values of different types. We're making a slice of book, so we could store multiple books there. Right at the beginning, we're saying there's 0. It'd be nice if we had row length, right? Like the number of results. We do rows next, and we create an empty, this is a composite literal, and we're saying there's no values. So we're creating that book. And then we're going to use rows scan, and we're going to pass in the address of this new composite literal for the ISBN, the title, the author, the price. And then we're going to append to our slice of book, right, this one book. And if error equals rows.error, error is not nil, panic error. So rows.error, if any that was encountered during iteration, error may be called after an explicit or implicit close. So if there's an error, we're going to shut down. And then finally, we're going to output our books. That's kind of cool. I like that. In the next video, we'll see it working, and then we'll try to create something ourselves, okay?